The next method we're using for the same pair of simultaneous equations is substitution. So this method requires us to substitute one equation into the other. Now, since both of these equal y at that point where they'll overlap, the y's will be the same, I can actually just write 3x plus 1, which is this equation 1, equals negative x take 3, because y equals y at that point of intersection. The y values are the same and the x values will be the same. So I've actually set up an equation that I can solve for x for. So let's remind us of some of our algebraic thinking. I've got 3x plus 1 equals negative x take 3. Now I want to get the x's to the same side, so let's get rid of this x on this side. So let's add x, add x. So therefore I've got 4x, still got to carry this plus 1, equals negative x plus x is 0, take away 3. Now I want to isolate the x on its own, so let's get rid of this one here, negative 1, negative 1. So therefore 4x plus 1 take 1 equals 0, equals negative 3 take 1 equals negative 4. Now I need to get rid of this 4 times, so let's divide both sides by 4. Therefore 4 divided by 4 is 1, so x equals negative 4 divided by 4 equals negative 1. So we've got the solution for x, and now we just have to substitute it into either one of these to find y. So let's take the second one, because I don't have to multiply out by too much. So I'm going to write sub into 2. So I'll just label them 1 and 2. And so we can go y equals negative 1 times negative 1 take 3, because negative, remember, negative x is the same as negative 1 times x. So all I've done is substituted the negative 1 here into there. Negative 1 times negative 1 gives me 1. And we still need to take away the 3. 1 take 3 equals negative 2. So that's y equals negative 2. I've got my x equals negative 1. So therefore the solution is negative 1 is our x, and negative 2 is our y. Again, you could write it as x equals negative 1 and y equals negative 2. Either way will do.